Hello everyone and welcome to chapter 6. We're going to go slide by slide as we always do, and we're going to complete the chapter 6. We're going to make sure that the essential concepts are discussed and you understand the chapter 6 well. So let's get started. Okay, chapter number 6, VLANs. Okay, and right here 6.1.1. Let's get started with this screen. Okay, let's see. VLANs. What is a VLAN or a virtual LAN? This entire chapter we're going to learn what VLANs are, how to configure them, how to troubleshoot them, what is trunking, what is access mode of switch port, what is inter VLAN routing. We're going to discuss all of those. Okay, so let's see. First of all, VLANs, we know virtual LAN. Look at this picture. That's going to tell us a little bit about virtual LANs. Here, it looks like it's a building, first, second, and third floor. On a different floor, I have some PCs from the first floor, some from the second, and some from the third floor. All of them belong to one segment of the LAN. A VLAN basically a segment of the LAN. Okay, but they are physically far away, physically attached to different switches. On the other hand, some computers, they are connected on the same PC, on the same switch, on different ports of the same switch, but they belong to a different VLAN. Okay, say there is a switch and two PCs are connected. One is connected on switch port number 1, one is on port number 5. Port number 1 is assigned to VLAN 10, and port number 5, that one is assigned to VLAN 20. So when one sends the broadcast, it's not going to go to the other one. Each VLAN is going to have its own subnet, own IP range, own subnet, for the IP. Therefore, broadcast traffic is not going to go from port 1 to port 5 because they belong to separate subnet, even though they are physically connected to the same switch. Isn't that cool? So again, I'm going to summarize, not to confuse you. Number one, each port of the switch can be configured to access a VLAN. Could be the same VLAN or could be different VLANs. So many computers could be connected to the same switch, but they may belong to different VLANs. Number one. Number two, some other PCs may be connected to a different switch. Okay, some are connected to switch 1, some are connected to the switch 2, some are connected to switch 3 in different floors per se, but they may share the same range of IP. They belong to the same subnet. Okay, so VLANs are interesting. So let's look at this picture again. So some PCs from third floor, some from second floor, some from first floor, they belong to the VLAN 1, and they on the other hand, look at this way across. On the many computers, they are connected to the second floor switch, but they belong to separate VLANs. Some computers to VLAN 1, VLAN 2, some to VLAN 3, some to VLAN 4. So they really cannot communicate with each other without going through a router, even though they're in the same floor. On the other hand, looking at vertically, these PCs belong to different floors, connected to different switches. However, they all can broadcast to each other. They belong to the same subnet. Interesting. So let's move on to know more about VLANs. Okay. Now, benefits of VLAN. Why do we do VLAN? Okay, let's look at this picture again to understand very, very well. Here, let's look at this switch on my left. On this switch, we are seeing port number 6 is assigned to VLAN 30. This PC3 belongs to VLAN 30. Port number 18 is assigned to VLAN 20. The name of the VLAN is students. Port number 11 assigned to VLAN 10. The name of the VLAN is faculty. Look at another switch on my right. Here I also have one PC, PC4, VLAN 10, another PC, PC5, VLAN 20, and the guest VLAN 30. Now, these two switches are connected to each other via another switch, and then we have a router. So let's understand how this communication is going to take place. PC1 on my left and PC4 on my right, they belong to the same subnet. They belong to the same VLAN. They are in the same network segment. Okay, even though physically they are far apart, but logically they have the same kind of IP, 172.17.10.24. 172.17.10, that's the range, that's the subnet. On the other hand, PC1, 172.17.10.21. So PC1 and PC4, they have the same range of IP, 172.17.10. Look at the PC2. PC2 has 172.17.20.21. And look at PC5, 172.17.20.25. So the PC5 and PC2, they belong to the same subnet. Okay, they belong to the same segment of the network. Very interesting. Okay, and so therefore PC1 and PC4, they can communicate. They belong to the same VLAN. They belong to the same IP segment, so they can communicate with each other without going through the router. On the other hand, if PC1 and PC2, they belong to the same switch, they're connected to the same switch, but belong to different VLANs, they cannot connect to each other directly. If PC1 has to send some data, it has to go through all the way here, go to the router. Router has to reroute it, then it's going to come back to PC2. So because they are in two different networks. Okay. Now let's, after understanding that, now let's understand the benefits of VLAN. Why do we do this? Number one is security. Okay, it increases the security. In the same room or in the same building, we have this switch. There are faculty computers and there are student computers. If I did not segment it out, if I did not logically put those two PCs in two separate subnets, then they could broadcast to each other. They could just reach each other without router. So I could not implement any kind of security. They could just easily ping each other, contact each other, communicate with each other. But in this case, since I have done VLAN, PC1 and PC2, they have to go through the router. And in the router, I can set all kinds of security, access list. So it improves security this way. Number two, cost reduction. See, again, PC1 and PC2 and PC3, they belong to three separate kind of people: faculty, student, and guest. However, they could not communicate with each other. Okay, a guest computer could not communicate with the student computer. The student computer could not with faculty computer without going through the permission and being permitted, being allowed, being routed by the router. Okay, but I did not have to create three separate network in structure. I would traditionally, without the VLAN, what would I have to do? I would have to buy a separate switch for the faculty network, another separate switch for the student, another separate switch for the guest. Three separate switches I would have to buy, and I would have to install. That would cost me more. But in this case, they are sharing the same switch, yet they cannot communicate with each other directly. Okay, so it's cost reduction. VLAN reduces our cost. Number three, better performance. Yes, when you divide the flat layer 2 networks into multiple logical groups, reduces unnecessary traffic on the network and it boosts performance. Yes, if PC1 sends a broadcast this time, normally the PC1 would send the broadcast and it would go through all of those that are connected to the switch. PC1 again sends the broadcast traditionally without VLAN. It would have gone to all the PCs here, PC2, 3, 4, 5, 6, because all of them are connected via switches. They would not have to go through the router. But now that we have the VLAN, if PC1 sends a broadcast, it will only go to PC4 because they are in the same subnet. So that's better performance. Unnecessary traffic, unnecessary broadcast is contained within the same segment only. Okay. Now, let's see. Reduces the size of the broadcast domain, as we just discussed. The same thing as bettering the performance, and improved IT staff efficiency. So here, because of the virtual LAN, the IT staffs also can put all kind of security measures. Their administration becomes easier with the same devices. Okay, and let's move on. Actually, we understood pretty much. Okay, types of VLANs. There are different types of VLANs. Okay, there are data VLANs, default VLAN, management VLAN, native VLAN, and let's see, voice VLAN. We didn't say it here, but there are. Okay. So by default, if you go to a switch and type this command, show VLAN brief, you're going to see that only there's one VLAN here, that is the default VLAN, VLAN 1, and there's 4 more, 1002, 1003, 1004, 1005. In a VLAN, in a switch that's brand new, you have not created any VLAN, you have not done any kind of VLAN. If you just type this command, show VLAN brief, this is what you're going to see. You're going to see your default VLAN is VLAN 1. Your active VLAN is the VLAN 1. Okay, all the ports in the switch, from switch fast Ethernet 1 to fast Ethernet 24, all of the ports, and gigabit 01 and gigabit 02, all the ports belong to, by default, on this one VLAN, this VLAN 1. Okay, meaning no other VLAN has been created, no other VLAN has been implemented, all belong to the same VLAN basically. These other VLAN 1002, 1003, 4, and 5, they are specialty VLANs. We don't need to worry about them. FDDI default, token ring, there's different kind of technology, not Ethernet. Okay, so we're not discussing those things in this chapter. Okay, so here's what we need to learn. All ports assigned to VLAN 1 by default, as we have seen right here. Now, native VLAN is VLAN 1 by default. Native VLAN, management VLAN, everything is VLAN 1 by default. Okay, because VLAN 1 is the only VLAN that's there, only Ethernet VLAN that you have right here. Now, VLAN 1 cannot be renamed or deleted. You can create other VLANs, like VLAN 20, VLAN 100, whatever, and name those VLANs, student, guest, faculty. You could create those VLANs, you can erase or delete those VLANs, but you could not do that to VLAN 1. Just remember that. Now, what is a data VLAN? Well, we just create a VLAN, say VLAN 100, VLAN 150, whatever we want to create. Let's create a new VLAN, and that's going to carry the user data traffic, just regular VLAN, as opposed to a voice VLAN. A voice VLAN would be creating the VoIP, voice over IP data. That's going to create the audio, that's going to take your audio data. We'll discuss that in some other slides, which will be coming soon. A default VLAN is the one that is already been created, that is the VLAN 1. We understand that. What is a native VLAN? Now, to explain native VLAN, we need to actually explain another concept first, like a trunking. Each of the switch port you can assign for one VLAN. Like the switch port number 1, I assign to VLAN 10. Okay, switch port 1 to 10, say percent. These 10 ports I can assign to VLAN 10 per se. Then switch port 11 to 20, say I'm going to assign to VLAN 20. Okay, so I have 2 separate VLANs now. Look at the scenario. But say gigabit 01, this port is connected to another switch. So all these VLANs, they all have to go through this port to go to the other switch. So the gigabit 01 port then has to be a trunk port, meaning that can carry all the VLANs. Okay. Now, when traffic is passing through all through a trunk port. What a trunk port does, trunk port says, hey, I am a trunk port. So VLAN 10, VLAN 20, VLAN 30, all separate VLANs, all are going through me to the other switch or to the router. So what do I do? How do I keep track when the traffic comes back that which VLAN it belongs to? What do I send? So it actually puts a tag on the traffic. So every time a packet, a frame is passing through the trunk port is going to put a tag on the traffic saying, okay, this is it. You belong to VLAN 10, okay? You belong to VLAN 20. You belong to VLAN 30. So each packet, each traffic, each frame is going to have a VLAN tag on them. Native VLAN is a VLAN. So you have VLAN 50. You named it. You want it to be native. What it means, that VLAN will not be tagged. When the native VLAN traffic, VLAN 50, that traffic passes through the trunk port is not going to tag that VLAN, that traffic. Okay, it's not going to say you belong to VLAN 50. It's not going to say that. No tag. Just simply let go. So that's called a native VLAN. Okay, we'll learn more about native VLAN in the upcoming slides in this chapter. Management VLAN. Just like you have VLAN 10 in the previous example for faculty, VLAN 20 for student, you create different VLANs. What is a management VLAN? Remember, sometimes we also access the switch itself from a remote location. My switch is in Dallas, I am in New York, and I'm going to SSH or I'm going to telnet to my switch. So switch also gets an IP address, not on any of those ports, not on this fast Ethernet port, none of those ports, but on the, we know this already many times, we have discussed that switch virtual interface, SVI. That interface is the management interface. That's how we access the switch to type in the commands to manage the switch, okay, to administer the network. Now that SVI, switch virtual interface, that one is the management VLAN. That belongs to the management VLAN. Whatever IP you assign on that IP is your management IP. That whatever VLAN that you're going to assign, that SVI, that's going to be your management VLAN. Okay. By default, again, VLAN 1 is the only VLAN that you have. That is your management VLAN by default. We'll also learn more in the upcoming slides on this. So let's move on. Now we're talking about voice VLAN. Okay, let's try to understand slowly. Here is a situation, here is a picture, a scenario. I have a router that is connected to switch 1, that is connected to switch 3. Now, switch 3 is my access switch. In here, this port number 18, on the switch 3, port number 18, I have two devices. One is this IP phone and also this PC5. So my computer, my PC, and my voice over IP phone, both are connected on one port, one single port, F18. How do we do that? Well, the VoIP, this phone has an extra port. This actually has 3 ports. We're going to see in other slides. Somewhere we're going to discuss that. So one of the ports of the IP phone is going to connect to the switch. Another port can connect to another voice over IP device. And another port here connects to my PC. That way, I did not occupy 2 separate ports, and I didn't have to run 2 separate cables all the way to the switch. One from the phone, one from the PC. They both are sitting on my desk. I did not have to run 2 separate cables directly to the switch of S3. Okay, they are connected with only one cable to the switch's F18 port. Okay, understood that. Now my PC belongs to VLAN 20 student PC, and my voice over IP phone, if that too would have belonged to VLAN 20, would be a security risk, would be a problem. In that case, I would also have to probably assign to a different port. But port number 18, port number 19, both of them would be would belong to VLAN 20. But now it's a unique situation that we are doing. Let me explain to you what we are doing. We are creating VLAN 20 for the student and a separate VLAN called voice VLAN, that is VLAN 150. And both VLANs can be assigned to this one port, F18. Very interesting. So this VLAN 150 is a voice VLAN that can coexist together with the VLAN 20, and they share the same port, F18. Yet, interesting part is that this PC could not tap this phone. They belong to two separate VLAN. Okay, they belong to two separate VLAN. Very interesting. So this PC, he could not hear, he could not interfere anything with this phone. Okay, no way that it could hack this phone, it could get in. No, the PC is using a different VLAN, different subnet. The voice is using a different VLAN. Okay, IP phone is using a different VLAN. Very interesting, but they are sharing the same port. Okay, so voice VLAN, just remember, is a special kind of VLAN that shares the same port with another device. Okay, just for your understanding. And why do we do that? Why didn't we use the same VLAN? Well, the same VLAN would get the same priority. Voice requires a higher priority, higher bandwidth. We discussed something in the CCNA 1, that is the QoS, quality of service. Voice requires prioritized traffic service. Okay, so voice cannot delay, then the voice will be distorted. When you're talking and somebody is listening, that could be distorted. You couldn't hear it, you couldn't understand it. That's why it has its dedicated prioritized access to the switch, even though they use the same port. Okay, next. Okay, now packet tracer, who hears the broadcast? Okay, interesting. Let's see what we're going to discuss. Look at the trunk that I was talking about, the trunk. Now let's understand this slowly. Okay, I have here VLAN 10 faculty staff, VLAN 20 students, VLAN 30 guest, VLAN 99 management and native. Fine. Now on the switch, Fast Ethernet 1 to 5 are trunk port. Fast Ethernet 11 to 17 are assigned to VLAN 10. 18 to 24 assigned to VLAN 20. Fast Ethernet 6 to 10 VLAN 30. Okay. Now look at the picture. Faculty, this computer PC1 belongs to VLAN 10 and connected to this F11. F11 and 217 is for VLAN 10. That's right. Okay. And look at the switch S3. S3 has similar configuration. PC4 belongs to VLAN 10. So PC1 and PC4, they belong to the same VLAN. Now, PC1 sends some data, they are VLAN 1. PC2 sends some data, that PC2 belongs to VLAN 20. And PC3 sends some data that belongs to VLAN 30. All three have separate kind of ports, so they don't interfere with each other. But look at right here, this connection right here. The connection between this S2 and S1. If you see my mouse moving, this connection is a specialty connection. Why? Because all three PCs eventually has to go through this port to go to the other switch. Also, the connection on my right, between S3 and S1, this connection also has to be a special connection because all the VLANs here, they all have to pass through the same port here. These are called the trunk ports. Okay, trunk ports are the ports which carry multiple VLANs, more than one VLAN. Okay, so VLAN trunks configured to support VLAN 10, 20, 30, and 99. As opposed to this connection right here, F11. F11 is that port is an access port. Access port means it supports only one VLAN. Look at F18. F18, this port is an access port. F6 is an access port. Only the F6 only carries VLAN 30 traffic. But look at F1, this F1 right here, that connection is a trunk port. Okay, so I hope you understood what is a trunk. And trunk port is configured by 802.11q. Okay, that is the trunk standard. We're going to learn how to issue this command. Okay, show how to configure a trunk, how to show a trunk, how to configure inter-VLAN routing. Those are coming. So just remember, a trunk port is called 802.1q enabled port. Okay, next. Okay, now controlling broadcast domains with VLANs. Yes, we do control broadcast domains with VLANs. Very simple. This time I'm going to give you this example of PC2. Look at this picture. Say PC2 is going to send a broadcast without having the VLAN scenario. Again, I'm talking about if we did not have these VLANs, then all this entire network, they are connected by a switch. They, if PC2 sends some broadcast, that would have gone through to all other PCs, but not in this case. Broadcast will be contained only to its own VLAN. So if PC2 sends a broadcast, it's going to only go to PC5 because these two PCs belong to the same VLAN, which is VLAN 20. In this case, they are, let's see, okay, 4021, 1740, 1740, 25. Now in this case, looks like that it's gonna go to everywhere because it's the same. They all belong to the same. In this case, looks like no VLAN has been done. So if I play it, it's gonna go to everybody. Look, it's gonna go to every single. See, all the pieces, everywhere. That's right. No VLAN is done in here. Now maybe the second picture will show us the VLAN. There you go. Now it shows VLAN. Okay. Now a broadcast is not gonna go to everybody. Only going to go to its own VLAN. So let's click on it. There you go. Because the PC1 belongs to VLAN 10 and PC4 belongs to VLAN 10. Only within the same VLAN you have your broadcast. So it contains the broadcast. Okay. Next. Tagging Ethernet frames for VLAN identification. Okay. So we're talking about now trunk port, my friends. Trunk port is that 802.1q. So what happens when some traffic goes through the trunk port, then you know that multiple VLANs, VLAN 10, VLAN 20, VLAN 30, all of those traffic are going through this one port. That's the trunk port we just discussed. So what does the trunk port do? Trunk port adds a tag right here. This tag, it adds a tag that shows this VID, VLAN ID, and a few other like priority and all of those. Okay, so just remember that the trunk port would add a VLAN tag to the frame so that it will be known, this frame will be known to belong to a particular VLAN. Okay, only for the native VLAN the trunk port would not tag. Okay, so right here, what is in the tag? There are some fields in the tag. Type, user priority, that's important. As I mentioned that for the voice VLAN, there would be the higher priority. Okay, so here type like Ethernet or frame relay, whatever kind of technology you're using. Then you have this CFI, okay, for the token ring frames. Don't worry about any of those things. Just think of this VLAN ID, that a 12-bit VLAN ID that will be added. So that's the thing that you need to really focus on right here, that each VLAN, each frame is going to have its VLAN ID. So you will know, all the switches will know this particular frame belongs to VLAN 10. This particular frame belongs to VLAN 20. That's the one thing you need to understand. Okay, next. Native VLANs and 802.1q tagging. So only, as I mentioned, that the trunk port is going to tag all the different VLANs. Right here, look, VLAN 1, VLAN 2, VLAN 3, different VLANs everywhere, and these are trunk ports. Trunk ports are going to add the tag to each one of those. If you say that my VLAN 1 is the native VLAN, then for VLAN 1 traffic, no tag will be added. That's all. Just remember that for the native VLAN, whatever VLAN you specify as a native VLAN, you are telling the trunk port, don't tag the traffic from this VLAN. If you say that my native VLAN is VLAN 1, then all this trunk port will not add the VLAN ID tag to the traffic that come from VLAN 1. It's going to tag all of the traffic. VLAN 2, VLAN 3, they will be tagged. But the traffic from VLAN 1 will not be tagged because you specified VLAN 1 as the native VLAN. Okay. Next. Okay, voice VLAN tagging. Okay. Now, voice VLAN is going to have a higher priority, as we know. Now look at this. This is a voice over IP phone. It's a Cisco phone. It has 3 ports. One port of it is connected to the switch. Another port is connected to this PC. And another port, it could connect to another Cisco phone, phone ACIS, ASIC. Okay, now configured to tag voice traffic frames with VLAN 150. Interesting that this port right here, this connection, look at this. This port between the phone and the switch, it is carrying both kind of traffic. How? What is the both kind of traffic? One is that voice traffic. When you're making a phone call, you pick up the receiver, make a phone call, that's going to go through this way, right? Also, you're sitting at the computer now, PC5. You're sending an email. That too is going to go through this way and go to the S3. So this connection right here between the phone and the S3 is carrying both traffics, your voice traffic and your data traffic. So those traffic have to be tagged. So the switch understands that the voice traffic has a higher priority, send it fast. So the voice traffic is going to belong to VLAN 150 in this case, that you have done assigned VLAN 150 for the voice. Okay. So it shows a command. Here we're using show interfaces F18 switch port. If you issue this command, then it's going to show detail about this particular interface, F18. Again, go back to the picture 1. F18 is the port where this IP's phone is connected. Okay, so F18 port, you're seeing the detail of it. Then you see, oh, okay, I see. On the F18 port, I see that it takes VLAN 20. It also takes VLAN 150 voice. Yes, it's taking both kind of traffics. Okay, and the trunking is .1q. Okay, remember 80.1.q, that's your trunking. Yes, so it's carrying both traffics. One is the data traffic from VLAN 20, one is the voice traffic from VLAN 150. That's all you need to know from this for now. Okay, now let's see. Next, now let's do these activities all together. Okay, what they're asking us to do, let's see. Drag the Ethernet frames, YOLO envelope, to the destination PCs for the scenario. Not all envelopes will be used in every scenario. Okay, fine. So this is the envelope. I'm going to take where it should go. I'm going to drag it to that one. Okay. Scenario 1. PC1 sends a broadcast. Which PCs will receive a copy of the broadcast frame? So PC1. PC1 belongs to which VLAN? VLAN 10. So if PC1 sends a broadcast, it's going to only go to other PCs that belong to only VLAN 10. So who else belong to VLAN 10? Only the PC4. So the broadcast is going to go only to PC4. That's it. Check. Correct. Okay. Now let's go to the second one. For an example, I'm going to go do another one for you. Now PC2 sends a broadcast. Which PCs will receive a copy of the broadcast? Well, PC2, right here is PC2. PC2 belongs to what? VLAN 30. This another PC here belongs to VLAN 30. They all in the same VLAN. So everybody in the same VLAN will receive the broadcast. There are more people here. VLAN 30, VLAN 30. Everybody, all the PCs everywhere that belong to VLAN 30, they are going to receive the broadcast. So this one, PC3 is going to receive it. PC4 is going to receive it. PC6 is going to receive it. They all belong to the VLAN 30, VLAN 30, VLAN 30. Okay, check. Correct. Okay, just like that. I'm not going to do the number 3, you do it. I'll leave it for you. Okay, next. Okay, and next. Okay, VLAN ranges on catalyst switches. What are the range of VLAN that you can create? What numbers? VLAN 1, VLAN 5, VLAN 1 million? No, no. Here is what you can do. You can do from VLAN 1 all the way to VLAN 4000. Okay, 4094 to be more specific. That's what your range. That's what you can do. But if you are a company that requires even more VLANs, okay. So I mean, right here, VLAN 1005. That's your range. See right here. Sorry, VLAN 1 to VLAN 1005. That's your normal range. But if you need more, then you could go up to 4096. Okay, these are called extended range. So any normal range, all we're talking about between VLAN 1 and VLAN 1005. Again, VLAN 1 is always taken, that's the default. 1002, 3, 4, 5, they are also taken, they're for special purpose. So what it leaves behind for you? VLAN 2 to all the way to 1001. These are the ones you can configure here. Okay. So as you see that between 1 and 1005, that's what you can create. 1002 and 2 through 5, they are reserved, as you see right here. 2, 3, 4, 5, they are reserved. Okay. So VLAN 1 and 1, okay, no problem. We already got it. Okay. Extended range. Extended range are between 1006 and 4094. Some companies, some very big enterprises in the world have that kind of need. They could create those VLANs. Okay, that's it. Let's move on. Now, how do we create a VLAN? Okay, what command do I type? That's what we're talking about here. Okay, only type VLAN ID, and let's see. I may just open up the packet tracer for you, just to show some of the commands. That will be more easy for me to for you to understand. Okay. Say I have a switch right here, 2960. I put it here, and I'm gonna do something in this switch. Okay, do some activities. Click on it, go into the switch. Okay, too small writing. Let's see, option, preferences, fonts, 8, go to 16, apply. Okay, now we have bigger size fonts for you to see. Okay. Okay. Enable. Okay, look at the show command first. Show, then just type V question mark. Okay, see, I could type show VLAN. Okay, fine, VLAN. After the VLAN, what? I'm going to do another question mark. I could do show VLAN brief. That's the command they showed us earlier. And then I could do show VLAN ID and an ID, like show VLAN ID then 20, or show VLAN name student. So in this case, I'm going to do show VLAN brief, BRIEF, and here I am. What you have seen in this chapter, we are doing it, we're showing it here in the switch. Okay, show VLAN brief. That command shows, as you saw in the earlier slides, that VLAN 1 is always there, already created. That is the one. All the ports by default belong to VLAN 1. We talked about it. Then from 1002 to 1005, they are reserved for a special purpose. So VLAN 1 is reserved, VLAN 1002 to 1005 reserved. Again, what that leaves for us to create VLAN 2 to all the way to 1001. Okay. Now, how do we create a VLAN? Okay. To create a VLAN, I have to go to the global config mode, config T. Okay. I would like to create VLAN 10 per se. So I'm going to type VLAN, and VLAN ID is 10. That's it. A VLAN is created. That's all. So I want to name this VLAN faculty. So I'm going to type name, NAME, faculty, FACU. Say I'm going to do with capital F per se. FACULTY, faculty. Okay, that's it. I have created a new VLAN named faculty, and the ID, VLAN's ID is 10. Is it done really? Yes, it is. Let me go to end, END, and now I'm in the privileged exec mode, right? I'm going to do show VLAN brief. Okay, enter. Now you see I have this new VLAN is there, VLAN 10 faculty. See, active. I have not assigned any of the ports to this VLAN yet. If I assign some of the ports from here to this VLAN, then it would show that those ports now belong to this faculty, that VLAN. Okay, that's how we do it. Okay, so that's what it's showing here for you, and it's showing in the picture. Configure terminal. Yes, we go to the config mode. VLAN, I did VLAN 10, they did VLAN 20, name student, and that's it. And they want you to practice here, so you should be able to do it. You just click on show me and you do it. No worries, practice at home. Okay, get going. Assigning ports to the VLAN. Now, how do I assign some of the ports to a VLAN? Let's talk about that. See, I go to the config mode, then I select that interface. Then I type switchport mode access, and then switchport access VLAN ID. Let me actually do it. That's why I brought up the packet tracer, so I can actually show you more on that. So here is my VLAN 10, right? So I want to assign port number 1 to 5, all of these 5 ports to this VLAN 10. How do I do that? Well, let's go to the global config mode. Config, CONFIG, config T. Okay. Now, I need to, whatever interface I'm talking about, I need to go to that interface mode first. Since I'm going to do 5 interfaces, I'm going to do a range. Okay. I'm going to type interface int range, interface range, fast Ethernet 0/1. See, I could do F0/1 or I could do FA. Either one works. Okay, I could have written here FA 0/1. That would also work. To 5. So now all 5 ports are selected. Okay, then I'm going to type switch port, SWI just tab, switch port, mode M just tab, access AC tab. See, switch port mode access. So all these switch port I'm going to put in the access mode. Access mode, when I put a switch port in the access mode, meaning only one VLAN is what is going to be assigned to. It's going to carry only one VLAN. It's going to belong to only one VLAN. Okay, as opposed to a trunk port. Switch port mode trunk, I would do that. Okay, and also see if I do a question mark here, so you can see, yes, I can have switch port mode access, I can have dynamic, and I can do trunk. Okay, dynamic would be set trunking mode to dynamic, negotiate access. So I'm not going to worry about that. Just no access and trunk. You can manually send. So I'm gonna write here access. Okay, so all those 5 ports has been set to access mode. Now, who is VLAN I'm going to assign them? VLAN 10. Okay, so I'm going to type switch port then access VLAN, just V tab VLAN. Which VLAN? VLAN 10. That's I created. Enter. That's it. Now those ports have been assigned to VLAN 10. I would like to show and verify it. End, end, back into the privileged exit mode. Now I'm going to type show VLAN brief again. Show VLAN brief, VLBR, okay, tab, enter. Now look at this interesting thing. VLAN 1 now has all these other ports from fast Ethernet 6 to all the way to gigabit 02, but VLAN 10 faculty, that VLAN now have these 5 ports. See, that's how we assign ports to a VLAN. Okay, so that's exactly what they're showing right here. Okay, configure terminal, go to the config, set the mode to access, and then switch port access VLAN. Then VLAN would be 10 or 20, whatever, 100, whatever you want to put here. Okay, so then go to all these next screens. Basically, you're doing all of those. Okay. Now, one interesting thing about the voice VLAN. So I have shown you the very basic thing. Look at this particular scenario in here. Interface F18. Look at this picture. F18, that is carrying two kind of traffic and two VLANs. One is the VLAN 150 from the IP phone and VLAN 20 from this student computer. See how they did on this one? Look at here. Interface F18. Switch port mode access. That part is right. Switch port access VLAN 20. As we did, everything's fine. One more thing they went. One more thing they wrote here. MLS, QoS, trust COS. You got to memorize that, my friends. MLS, QoS, trust COS. You do this only for the voice VLAN, for no other reason. Then you type switch port voice VLAN 150, and just these two lines additionally added. That's all. So again, if a port, for every port that's going to have just one VLAN, all you have to do is just this part, the upper part right here. Switch port access VLAN 20. You're done. If a particular port is carrying additionally a voice VLAN, then you have to add these two other lines. MLS, QoS, trust COS. Switch port voice VLAN 1. That's it. Okay. So now here they're gonna ask you to practice. Okay. So you go ahead and do show me each one and keep on doing and keep on doing and keep on doing. You're gonna be learning those. Okay. So you're gonna learn to type this MLS, QoS, all of those. Okay. Right here. So right here, MLS, QoS. So you just click on the show me and it's gonna show you and practice home. Okay, next. Okay, changing VLAN port for membership. Okay, so a port, if I in this case, look at my scenario here. Where is my packet tracer? Switch. Okay, in this case, I have port number 1 to port number 5. They have been assigned to F05. The VLAN 10, VLAN 10 faculty VLAN. But then I say, oopsie, I did a mistake. On the port number 5, I really should not assign it to VLAN 10. I should assign to VLAN 20. I'm going to go ahead and create the VLAN 20 and take this port number 5 away from the VLAN 10 and assign this port number 5 to VLAN 20. How do I do that? So let's go ahead and create another VLAN, VLAN 20. So I'm going to go back to config mode, config, config T. Okay, I'm back in the config mode. I'm going to create another VLAN. Just type VLAN, very easy commands, VLAN, and then VLAN ID is what? 20. That's it. Enter. VLAN 20 is created. Say I'm going to name that student. I'm going to type name student, say capital S. I'm going to do student. Okay, and I'm going to say S, students. Fine. Enter. Now that students VLAN have been created, but no ports have been assigned. So what I want to do, I want to go to the port number 5 and I would like to take the port number 5 away from VLAN 10 and then reassign it to VLAN 20. Okay, so right now I'm in the VLAN mode, so I'm going to exit from there back into the config mode. I would like to go to the Fast Ethernet 05, that interface, and take it away from the VLAN 10. So here's how I do it. Type interface, tab, interface, Fast Ethernet 05. Okay, so now Fast Ethernet 05 is selected. So I'm going to type no. How did I assign the VLAN 10? I type switch port access VLAN 10. Okay, this way, switch port access VLAN 10. That's what I did earlier. So what I have to do now, I have to do just add no, but then I don't have to do the 10 anymore. What I'm going to do is this. Look, just no switch port access VLAN. That means this, if I issue this command, the port number 5 will not belong to any VLAN anymore. Okay, no switch port access VLAN. Enter. Boom. It's not belonging to any VLAN, meaning it went back to VLAN 1, the default VLAN. Now I'm going to assign it to VLAN 20. How do I do that? I'm going to type switch port access VLAN 20. So now it's going to belong to VLAN 20. There you are. Okay. Then I'm going to type end and go to show VLAN brief. VLAN BRIEF brief. Okay. And see what happened now. Look at that. VLAN 1 again has all these ports. VLAN 10 now has between 1 to 4, these 4 ports. And VLAN 20 students, that one has the VLAN 5. Sorry, port number 5. Port number 5 has been assigned to VLAN 20. Okay, I hope you understood. That's what it's showing you in here. So if I actually do it for you, then you learn it easily. Okay, so first you did no switch port to take it away, to relieve that port from any VLAN association. That's it. This is showing you same thing that I just showed you, similar thing. Not exactly the same, but similar. Okay. Okay, now next, deleting VLANs. Okay, so all you have to do is no VLAN ID, global configuration mode. Okay, that's how we delete. To create, just type VLAN 20. So I'm going to create a VLAN 30, and then I'm going to delete a VLAN 30. Delete that VLAN. Okay, I'm going to go to the config mode. Config T. I'm in the configuration mode. I'm going to create a brand new VLAN. VLAN 30. Okay, and name, I don't have to do the name. If I do not do a name, that's okay. Name is not mandatory, but I'm going to name it, say guest, G-U-E-S-T. Yes, I'm going to put guests. Okay, now I'm going to go to end, and I'm going to go to show command again, show VLAN brief, to see that new VLAN. Okay, I see, yeah, VLAN 20 is there, VLAN 30 is there, VLAN guest, all of those. VLAN 30 guest is created, nothing has been, no port has been assigned to it yet. Good. I'm going to go ahead and delete that VLAN. How do I do that? Go to config mode, again, config T, type, last time what I did, I typed VLAN 30. That's all that was my command. See, VLAN 30. All I have to do is add the word no to it. That's it. Okay. So I'm going to type no VLAN 30. So VLAN 30 will be there no more. Okay. So I'm going to go to exit and type show VLAN brief again, just to see whether it has been gone. VLAN brief. Enter. Yeah, VLAN 30 is not there anymore. Only VLAN 10 and 20. No more 30. So that's what they're teaching you here. Okay. So let's move on. Okay. Verifying VLAN information. Okay. How do you do VLAN information? Remember we had just done show VLAN brief, or we could do show VLAN ID and then VLAN ID or name. Let me show all three of them. Show VLAN brief and show VLAN with an ID, show VLAN name. Let's do that. Okay, here I am. I'm going to type show VLAN. You already have seen show VLAN brief. I just did it here. So I'm going to type show VLAN ID and say 10. I'm going to see that one. So only one VLAN I'm showing right now. VLAN 10, that is faculty, is active, has these ports assigned to it. See? So I could do show VLAN and with a particular VLAN ID 10. Or I could do show VLAN and then name. Okay? I can just do an up arrow key right now, automatically types up, and I can go backspace, show VLAN name. Name should be, say, students per se, students, students. That one I would like to see. Yeah, it shows that VLAN ID is 20 is Ethernet, that kind of VLAN. Okay, and all kind of information that you don't really worry about. Okay, now look at here. So show interfaces command. So here I had the show VLAN command. Now I have show interfaces command. Show interfaces with interface ID and or VLAN ID and Swiss port. I could say that. Okay, and look at all these things syntax. Show VLAN name student. Show it here. Show interfaces VLAN 20. Yes, you can do that. Okay. This time I'm not using show VLAN command. I'm using show interfaces command. Just like that. So you're already seeing here. I don't have to really type up. I could, but don't worry about it. Next. Okay. Now configuring the trunk port. How do I configure? We already saw how do I configure an access port to access one particular VLAN. Now how do I configure a port as a trunk port? All I have to do is, last time I did Swiss port mode access. Now we're going to do Swiss port mode trunk. That's the thing. Okay, Swiss port mode trunk. So that port becomes a trunk port. That's all I have to do. Okay. So and then if I want to add, by default the Swiss trunk port is going to allow all the VLANs, every single VLAN. Unless you want to specify certain VLANs, then it's gonna carry only those VLANs. Okay. If you want to specify a port as a native port, then Swiss port, the trunk port, will not tag that particular, VLAN only. Okay. So these are your commands right here. Okay. So if I want to put the gigabit port as the trunk port, then I'm going to go to the gigabit interface. I'm going to type interface ID, Swiss port mode trunk, and the native VLAN could be 1, 99, anything, whatever. And Swiss port trunk allowed VLANs. So I'm going to at least put a trunk mode. Okay. In this case, look at this picture right here. VLAN 10, 20, 30, 99. All of these VLANs they have. This connection right here is a trunk port, because all the VLANs here have to pass through this one port to go out of the switch. That's a trunk port. Okay, and they're going to configure that. See, Swiss port mode trunk, Swiss port mode trunk native VLAN 99 in their case. Swiss port trunk allowed VLANs. They didn't have to do that. This is an optional. They wanted those VLANs to pass through this trunk. If they did not write this line, Swiss port trunk allowed VLANs, it would have been okay. All the VLANs would be allowed by default. Okay. So if I were to go, I'm in the privileged exec mode. I need to go to the global config mode, config T, and then I can go to that, say, gigabit 01, that interface. This interface right here, gigabit 01, I would like to make it a trunk port per se. I could do any port, doesn't have to be the gigabit port only. So normally you do a gigabit port that's because it's gonna pass through all the traffic and is connected to a router. Typically you do, but it's not required of you. So I'm gonna go to the gigabit. I'm gonna type interface gigabit 01. Okay, that interface. I'm gonna type Swiss port mode trunk, tr tab trunk. That's it. It has become a trunk port. I don't really have to type Swiss port VLAN and a trunk, switch port trunk, allowed VLAN. I don't have to really say those things. All the VLANs are allowed right now. Okay, and let's see, and so at least you will be able to see that this trunk port is not belonging to that VLAN anymore. I'm going to type show VLAN brief. Okay. So I have this VLAN 05, this one. Actually, trunk port as of right now is still showing in the gigabit 01. I'm not going to worry about it. Just let's move on. We have to do more configuration for that. Not going to talk about that yet. Let's keep on going. Okay, resetting the trunk to default state. Okay, if I do not want a port to be trunk anymore, then all I have to do that no switch port trunk allowed VLAN, no switch port trunk native VLAN. That's it. Okay, just do a with a no. Okay, this one right here, this particular interface, no switch port trunk. Okay, show interfaces. Okay, very good. You can do show interfaces command right here. Switch port mode access. You can show a particular interface now. It has become an access port mode. Okay, so it's no longer a trunk port. Okay, showed you there. Move on. Verifying trunk configuration. Once you created the trunk, you want to verify it. Okay, show interfaces with interface ID and switch port. That command is very, very good command. Show interfaces with interface ID, switch port. Okay, and right here, I'm going to do that for you. I'm going to type show interfaces with interface ID is gigabit 01 per se, and then I'm going to have switch port. That's my command. Enter. Okay. See, its mode is trunk. Okay, mode is trunk. Name gigabit 01. Switch port enabled. Mode is trunk. Operational mode down. I have nothing plugged in because for this trunk, I have to actually connect that to the other end, to a router or another switch or whatever. That end has to be configured. All those things. I have not done any of those things yet. Okay. Okay. So VLANs. Look, trunking VLANs enabled all. Okay. So look at capture VLANs allowed all. Okay, for right now. Okay. So anyway, go back to the chapter book. Okay. So I'm just trying to go to so much detail. You can practice here. No worries. Next. Okay. Configuring VLANs and trunking. Okay. IP addressing issue with VLANs. For each VLAN that you have, you're going to have one range of IP, one subnet for each VLAN. Okay. Two VLANs you're not going to do with same range of IP. Two VLANs will not share the same IP subnet segment. Okay. So VLAN 10, 172, 172.10.21. 172 should be 17, VLAN 10, or should be 17, I see, not 172. 17, 10, 21, 10, 30. Yeah, they all belong to the same. As long as they belong to the VLAN 10, they have the same range of IP. Okay, we know how to do IP config. Okay, in the PC, yeah, we can do IP config. That's no worries. These things are all something we understand, we know, we have done many times. Let's go. Missing VLANs. Okay, here we are doing a troubleshooting. I'm not going to go much detail on the troubleshooting. When a lab comes, we're going to do that practically in the lab. So basically, be familiar with show VLAN, show MAC address table, these commands. Show VLAN, show interfaces switch port, these commands you're going to be using for troubleshooting. I'm not going to discuss more detail of if this happens then what, I leave it there. We'll do that in the labs. Okay, troubleshooting trunks, I leave it there also. But you need to learn this show interfaces trunk command. And I believe that at this time that I created the trunk, it's not going to show interfaces trunk. Right now it's going to be blank for me. If I type show interfaces, unless it's fully up and running, show interfaces trunk. Okay, enter. Yeah, nothing. It shows nothing at the moment. Blank. Okay. Normally it has to be the other end also configured and everything. Okay. Now, very good. Okay, next. Common problems with trunk. Native VLAN mismatch. If you really, right here, this is something I would like to discuss a little bit. Common problem with trunk port. The problem, native VLAN mismatch. What does that mean? What happened? Remember the two sides, two switches are connected. On the switch 1 and switch 2, they are connected via a link, and this link is a trunk link. Okay, so on the switch 1 you specified that VLAN 99 being the native VLAN. On the switch 2, on the other hand, you mistakenly configured that VLAN 88 is your native VLAN. That's when the mismatch happens. In both sides of the connections, in two switches that you have, you specify different VLANs as your native VLAN. What happens if you do that? Then poses a security risk and creates unintended results. For example, one port is identified as VLAN 99, one is 100. Okay, it's going to have a security risk and unintended results that's going to have. Okay, why? Because it's going to be tagging. It's not going to tag in one end. It's not going to tag the VLAN 99 because it says native VLAN. I don't need to tag. But on the other end of the switch, it's going to start tagging. It's going to say this not tagged. So the wrong, it's going to be wrongly identified. That's why it has a security risk. Two switches are going to be all confused that which want to tag and which are not to tag. Okay, trunk mode mismatch. Okay, if you have the mode, trunk mode has this .1q, A2.1q, that if you have a mismatch, then you're going to have a loss of connectivity. Here, for the Ethernet, we always use the 802.1. 802.1 1.q, that is our trunk. Okay, just remember 1.q, that's the one. Okay, causes unexpected traffic or no traffic if you have allowed VLANs on the trunk. Now, if you have a mismatch on the allowed VLANs on the trunk, of course, you are specifying which VLANs to allow. You did VLAN 10, VLAN 20, VLAN 30, allowed. On the other end, you are saying that just do VLAN 40, VLAN 50, then it's going to be seriously a problem. Traffic is not going to go through. So allowed VLANs also should be the same on the both ends. Just remember that. Native VLAN has to be configured in the same both end. The trunking mode has to be the same, and allowed VLANs has to be the same on both end in both switches. Just remember that. Next, incorrect port mode. Okay, switch port mode trunk or switch port mode access. Okay, there are two kind of mode. Okay, here between these, typically between a switch and another switch, that port would be a trunk port for you. Okay, so switch to switch, those are trunk ports. But from PC, this PC to switch, that's an access port. Even this port does not carry multiple VLANs. It's carry only one VLAN. But this port right here, between S3 to S1, this connection, fast Ethernet 3 to fast Ethernet 3 in here, this connection is a trunk port. It has to allow all the VLANs that has to pass through. Okay, so make sure that you put the right port. See port 11 right here in this picture. Port number 11 is connected to PC4. That you need to set in access mode, and assign the VLAN 10 to this port. This port should be assigned to VLAN 10. On the other hand, fast Ethernet 03, that port should be a trunk port. So it's going to carry all the VLANs, okay, on both ends. No mismatch. That's it. Okay. Okay. Good. Next. Incorrect VLAN list. Okay. Switch port trunk allowed VLANs, making sure that the correct VLANs are being allowed. Okay. Again, right here shows in switch S3. Okay. Output from S3 shows that fast Ethernet 3 has is a trunk port has VLAN 10, 20, and 99. And look at the output from switch 1. Switch 1 says its fast Ethernet 3, which are connected together, these two fast Ethernet ports, only 10 and 99, not the 20. It's missing. Okay, incorrect list. So you got to correct those things. This is pretty simple, straightforward. That's all we are discussing, that both ends of the connection in both switches have the same trunking information. Same mode of the trunk, say 802.1, sorry, 802.1 Q, 802.1 Q, same thing in both sides. The allowed VLANs should be the same on both sides. Okay, that's all we're talking about. Okay, packet tracer. Okay, now we're talking about something else, very important concept. What is inter-VLAN routing? Okay, inter-VLAN routing is an important thing, and we must learn it. Now, we know that traffic from one VLAN to another VLAN, it has to go through the router, because each VLAN has a different segment of IP address. So, in other words, if two PCs are connected on the same switch, one is on the port number 1, another is on port number 2, but they belong to two separate VLANs. They could not communicate directly. They have to go all the way to a router. Router has to route it, then it has to come back to the other port. Okay. Now, how do we do that? That is called inter-VLAN routing. Okay. There are different ways to do that. Like we have the legacy type. This looks like the legacy type. Here is VLAN 30. They're in the same switch. Both PCs connected to the same switch. One is VLAN 10, one is VLAN 30. So they cannot just directly connect through here. Go PC3 cannot send data directly to PC1 via this switch. It cannot. It has to go to switch 2 all the way to router 1, then come back with fast Ethernet port 01, and then go to 011 and go to the PC1. It has to go through the router. Okay. Now let's talk about more. 3 different ways to do that. One is legacy inner VLAN routing, router on a stick, and layer 3 switching using SVIs. These 3 ways we configure routing between VLANs. Okay, routing between VLANs is called the inter-VLAN routing. Okay, let's learn one by one what they are. Here is the legacy type. Legacy type is very simple. We know that routers, what do the routers do? They connect multiple networks together. They connect multiple segments of IP, multiple subnets together. Routers have interfaces like, say, gigabit 01, gigabit 02, and so on. Okay, serial 01, 001, things like that. So all those interfaces, each interface of the router is going to be connecting a segment, a network. Okay. Now, in this case, if I have two separate VLANs, say VLAN 10 and VLAN 30 in this case. So we are using 2 hands of this router, 2 interfaces from this router. Look at gigabit 00 and gigabit 01. Both hands of the router, both interfaces are taken in order to route, in order to connect these 2 VLANs. So this switch has 2 connections with this router. Interesting. That is the old way. You are occupying both interfaces of the router, okay, with this in this situation. So you need more router interfaces. You need to buy more routers if you have like 5 different VLANs. Think about that. That is the legacy way. Okay, legacy. So how to remember? Legacy is the old way. Old way is what? Each VLAN is connecting to one interface of the router. Okay, each VLAN requires a separate interface from the router. That's the legacy. Easy to understand. Okay. Now, next, what is the other one? Other one is better. It's more modern. That's called router on a stick. So easy way to remember, easy way to understand it. That only one connection. That's why I call router on a stick. You have a stick, you have a router on it. Okay, router on a stick, it is requiring only one hand, only one interface of this router to connect many VLANs. In this case, I have VLAN 10, VLAN 20, VLAN 30. My lord, all three VLANs are working here with only one connection, only one interface of the router, just gigabit 00 per se. But what I did, yes, it's gigabit 00. I had to create sub interfaces. Very interesting. Sub interfaces, not just interface. Interface is what? Gigabit 00. So I did gigabit 00.10, gigabit 00.30, gigabit 00.20, and all of those. Okay, each one is connecting to a different subnet, different network. Okay, whereas physically it's only one connection. Physically only one connection, but virtually, logically, I created sub interfaces on the same port. Okay, this is called router in a stick. Router on a stick. Okay, and in this case, all PC1, PC2, PC3, all those different VLANs, they all go through this is a trunk port. They all go through the router, all of them with one physical connection only. Okay. And we'll learn how to do that. Okay, so just to show you an example, let's go to the slides first. Now let us do this activity together. Okay, in this case, what it's being, I have this PC1, PC2, PC3, they all are connected. Look at that, R1 router, just gigabit 00 trunk link. Oh, I see, this is a trunk link. I have multiple VLANs here, all going through this one physical connection only. This router on a stick. For these three VLANs, look, VLAN 10, VLAN 20, VLAN 30, for these three VLANs, I don't have three separate connections in here, only one connection. One connection, router on a stick. Okay, so I drag this one and check. Yeah, correct. Okay. Now, number two, look at in this situation. This is a multi-layer switch. It's not a traditional router. It's a switch and a router, multi-layer switch. Okay, so we're understanding already that is multiple connection and all of those in here. So this will be multi-layer switch. Check, correct. Go to number three. In this situation, I have two VLANs, VLAN 10 and VLAN 20. Two separate PCs, but we're using two separate connections with the router. That's the legacy. Good. So let's move on. Okay, this is a legacy situation. Okay, two separate connections with the router. Okay, configured. The legacy is the traditional configuration. I'm not going to worry about that. Okay, we're going to learn more the router on a stick. Okay, legacy, all it's doing right now, I'm in the switch. In the switch port, we're doing switch port access VLAN 30. We know these things. We're assigning switch port 11 for the VLAN 10, switch port number 4 for VLAN 10, port number 6 for VLAN 30, port number 5 for VLAN 30, things like that. We're doing all of those things. But then at the end, two separate connections on the router we're going to do. Okay, configuring legacy. Now we're in the router. In the router, gigabit 00 we are using and gigabit 01. Both interfaces. Look at this in this picture right here. Gigabit 000 is getting an interface ID, just like we traditionally do a router. Interface 01 is going to get another VLAN, another IP address. That's, acting like two separate networks being connected by the router. Simple. Next. But router on a stick is what I want you to learn. There you get to learn how to create these sub interfaces. Okay, I'm going to show you that. In this case, we have a router, gigabit 00 interface. Only one interface is being used for all three VLANs, VLAN 10, VLAN 20, VLAN 30. Okay, so, and each time PC1 or it wants to send something to PC3, it has to go all the way to router and click on this play, and you're going to see. Okay, all the way to the router. The router has to route, then it's going to another VLAN, coming back, and then it's going to go. That packet is going to come back. Router is going to do the routing on the same interface, and coming back to the other PC. Okay. Now we'll show you how to do the configuration. Okay. Next. Okay. How do we create this sub interface? Gigabit 00, we knew these things, but dot 10, dot 30. Okay. And right now we are doing it in the switch. In the switch, we already have learned how to do the switch port mode trunk. Now let's learn how to do it in the router. Here we are in the router. We go to that interface, encapsulation.1q, and the VLAN ID, IP address, interface.30, encapsulation.1q. Okay, so you just go to an interface, do the encapsulation, do the IP address. Okay, let me show you so you don't get confused. That way you're going to learn. I have a switch. Now I'm going to have a router. Here is a router. 1941. Okay, here is a router. Okay, let me get them connected. I have a copper cable, say gigabit 01. I'm gonna connect here to gigabit 00 per se. Okay, they are connected. I'm gonna go to the router. In the router, I'm gonna go here. Okay, make it bigger. CLI. Okay, no. Okay. Enable. Okay. Config. T. I'm in the global config mode. Okay, the router has this gigabit 00 interface. Normally we go to the interface gigabit 00, assign the IP address and subnet mask. Not anymore. I'm gonna now do, say I have VLAN 10, VLAN 20, VLAN 30. So what I'm gonna do, I'm gonna type interface tab gigabit 0/0 dot 10. What is that from? We are creating sub interfaces. This is called a sub interface. Okay, enter. I'm in the sub interface mode now. Okay, because I'm going to use that gigabit 00, that one interface only for three VLANs, VLAN 10, VLAN 20, VLAN 30. They're going to use, all of them are going to use this gigabit 00, only one interface, only one port. That's why I'm creating sub interfaces. Okay, then I'm going to type this command, encapsulation, EMC tab, see encapsulation dot 1q. Okay, and then we're going to have the VLAN ID. Okay, encapsulation dot 1q, then we're going to do the VLAN ID. So right here is this 10. This 10 is actually your VLAN ID. Okay, that's important. And then you put the IP address. Okay, so going back there, so my VLAN ID is 10. Okay, so now, so I'm adding this VLAN 10 to this sub interface gigabit 00.10. Okay, and then I'm going to have an IP address. Say IP address would be 192.168.10.1, subnet mask 255.255.255.0, something like that. Okay, so say I have several subnets. One subnet has 10, 192.168.10. Another subnet has 192.168.20. Another subnet, so three separate subnetwork. Okay, three separate network I have. IP address is done. And I'm not going to do no shutdown. Interesting. I don't do no shutdown on the sub interface. Right now I'm in the sub interface. I'm going to do no shutdown on the main interface. Okay, so I'm going to go exit out of there. Done. I'm going to do another sub interface. I'm going to type interface gigabit 00.20. Another sub interface. Okay, encapsulation dot 1Q, and this is VLAN 20. My VLAN ID 20, VLAN 20. Okay, and I'm saying now the new IP address on this one. IP address, it's that VLAN's IP address, whatever the IP address is, 192.168.20.1 subnet mask 255.255.255.0. Done. Okay, so I created two sub interfaces. Exit. So I'm out of the sub interface. Do you know how I'm going to have to assign the? So I did only two. I didn't do the three yet. I'm gonna just do two to show you. .10 and .20, these two sub interfaces, and I assign IP addresses to them. Okay, VLAN for VLAN 10 and for VLAN 20. Here's the VLAN 10. Here's the VLAN 20. It's gonna be trunk port. Okay, now how do I do the no shutdown? I don't do the no shutdown on the sub interface. I do the no shutdown on the interface. Okay, so I'm gonna type interface gigabit 00, not on the sub interface, not .10, not .20, no, just this interface. Enter. Then I type no shutdown. Okay, see, it all became up. All these sub interfaces became up now. Okay, now so here is my topology right now. So this one is now showing green. I configured them. I do fast forward time, all become green now. Okay, so that's what they are teaching you right here in the book, that you do go to a sub interface, do the encapsulation, put the IP address, and another sub interface, and keep on going like that, as many VLAN as you need. Okay, next, router on a stick. Okay, you're gonna practice here. You're gonna practice those commands. Do that at home. If you didn't know, again, if you didn't understand, you do show me, and it's going to show you. Okay, next. Configure router on the stick, verifying routing. Okay, you can do the ping to verify. There's nothing new. We'll do that when we do the lab. Okay. Okay, so that concludes our chapter. That concludes the basic concepts of this chapter. I hope that this video was helpful. And let's see, why not my mouse working right host only. Okay, so we are done with chapter number 6, but my friends, I just noticed that on the assignment on chapter 6 we have let's see, we have many labs. 6.2, 6.2, 6.2, many of the 6. Oh my lord, let's see how many. 1, 2, 3, 4, 5, 6 labs. So we're gonna be busy doing labs. Tomorrow is Thursday. Not tomorrow. I'm gonna be doing I may even do some labs tomorrow. I may do some labs tomorrow, and maybe a couple of labs I'm gonna do tomorrow. Okay. So sometimes I just come to the online. I'm not going to give you too much notification anymore. Just come online sometimes between 10 and 1. Between 10 and 1. So I hope that you all have a wonderful day. This class is, I'm going to be looking forward to see you all tomorrow again to do the labs. Okay.